Okay, and we are live. Thank you to everyone and welcome for tuning in. I am Boris. I'm hosting this week's Aligned guest stream, and I am super excited to be hosting our friends from Giza, Cem, who's a co-founder, and Raphael, who leads zkML. I think we're gonna have a fun conversation today about zkML and how this empowers AI agents on chain. We are big fans of Giza's work, and we're working with them on a few cool things. So again, welcome, Cem and Raphael. How are you guys doing?
We're doing great. A lot is going on in the world, but we promise not to steer away from what brings us here, which is the future of Web3, on-chain agents. And yeah, like when we focus on what's in front of us, we are doing great. Otherwise, the world is constantly trying to distract us.
Oh, sorry, my audio just cut out. 1 second. Okay. Can you guys hear me?
Yep.
Yeah.
Cool. There's a little glitch. Yeah. There's definitely a lot of crazy stuff happening, but but also a lot of really interesting things and really, really positive things to look forward to, including technology, of course, which is what we're here to talk about. So I was thinking maybe we can start with just like quick introductions to give some context on your guys' backgrounds and Giza, of course, and like the journey to what you're working on now. I like to start with this because I think I personally find it interesting. I think others do too.
Raf, you want to go first?
Yeah, okay, maybe. So I'm Raphael. I joined Giza at the really beginning of Giza. Before I was working on as a smart contract developer in a company called Revelator, where we were building some protocols for the music industry. And then before that, I was working on some AI and ML stuff at the university. And just before Giza, like ChatGPT was launched, and like I realized that we need like to have integrity of the computation for the inference of ML models. So I was like started working on some projects and a library that I called the Cairo ML that was like doing like machine learning library in Cairo. And then I tweeted a lot about the progress of the project, etc. And Fran from Giza sent me a message and said, "Hey, we are working on something similar. So if you want, we can join our work." And this is how I started my journey at Giza. And since then, like I'm working on the zkML part at Giza, trying to make our the decision making of our agents verifiable. I think we will discuss about it today. So yeah, this is basically who I am and what I'm doing at Giza. Cem, I give you the mic and to present maybe also Giza of what we are doing.
Yeah, of course. Yeah, I have a marginally different background than Raf. I come from investment banking. Then I had a brief period of Web2 entrepreneurship. From then on, I think I met Ethereum around its ICO and went full-time working with kind of an anarcho-punk squad, building eccentric DAO tooling. Basically, we were at the time trying to convert a version control system into a democratically governed repository. So the project was called Panda Network. OGs will know. And then, I started basically being kind of attracted by this programmable organizations' vision, and how kind of this, in my mind, was the gateway towards political, socio-political, economic experimentation. So I really invested a lot of time and effort into that, primarily building, again, DAO tooling, but it's obviously, like in Web3, became financialized quite rapidly. We built some of the first state-of-the-art implementations of bonding curves. It was done with Aragon at the time, called Aragon Fundraising. And then from there on, I established my venture builder company called Curve Labs, where we were engaging with a bunch of tokenomics, governance design, and a lot of experimental kind of artistic communities, again, like Web3 affordances that could be utilized for experimental, financial, social organization. But over this kind of, let's say, 5-6 year long career in Web3, I was becoming really pretty frustrated about the affordances of mechanism design, especially with open source software, because you're building essentially a game theoretic architectures that needs to withstand all kinds of attacks, and you know, in a publicly available, visible manner, which corners you as a designer quite rapidly into kind of expressing a very limited language, because again, like, there's such a high threshold of requirement of security and game theoretic soundness that yeah, it limited the design space significantly. And with Giza, pretty much our intention has been to intervene into expanding that design space in a very non-linear manner, you know, not like making just another kind of smart contract design pattern, but making a non-linear jump by figuring out this key component, which I guess is what brings us together, which is figuring out the trust element of bringing machine learning and AI into smart contract applications. Yeah, this has been our mission since the beginning, which is porting intelligence to trust networks, permissionless systems. And that basically had as its mandate figuring out how to raise the level of trust that both users and protocols could garner towards machine learning and AI systems. And one big component of that, of course, is cryptography. Raphael will talk more deeply about that. But of course, there's other elements that we are working with, like crypto economics. So what we do, and other primitives like session keys and smart accounts, that is key aspects of our architecture. By bringing all of these together, Giza provides a unique stack that does this in production today. And yeah, what we want to enable is basically a radical accessibility for the future users of Web3, because with such high complexity and entry barriers, Web3 is always going to be limited to a circle of enthusiasts or you know, financial beneficiaries that you know, that doesn't necessarily have radical prospects of growth. So what we want to enable is a new paradigm of accessibility of all the values that Web3 is able to provide to end users. And we do this by utilizing self-executing, operationally precise and disciplined agents that can provide financial functionality at a level and effectiveness that is much higher than human performance, and at a level of trust that everyone can rely on.
Incredible. I just put you as a spotlight so I could get like a really nice clip of you saying all that, because I was like, this is excellent. Cem, yeah, wow, a lot to discuss. I wanted to say, actually, like, starting off, because there's a few things that really resonated with me. DAOs are also one of the main things that got me interested in crypto and Web3 initially. When I started to understand, what Ethereum enabled, and the benefits of a permissionless system and trustlessness. And then, of course, through DeFi, I think we interacted a little bit through like LabDAO stuff way back when I didn't really understand how Ethereum worked, and I had never heard of zk. But yeah, everything you just said, that's incredible. And I want to dig into a few of those topics in particular, because I mean, everything you just said, like specifically what you're working on now with Giza, verifiable on-chain agents, verifiable machine learning, things that can perform better than a human faster, taking in more information. A lot of these things kind of only became possible more recently, I guess, right? Like, we, over the last couple of years, saw LLMs really explode in popularity and capabilities. Maybe crypto hasn't changed quite as much in that time period, except for, of course, zk. So I'm really curious to hear about, I don't know, the thought process, or like how you started thinking about agents and realizing they were going to be important on chain. Was there technology that still didn't exist when you first had these ideas? Like, where did the idea of combining verifiable machine learning with on-chain agents start to cook?
I'll let Raphael answer as well, but for me it was this moment where my co-founder Fran, he demonstrated to us in a very tangible way from a hack that he had done in some ETH events. I forget which one, but very tangible demonstration of providing a zk proof associated to an ML inference, which really got me over the edge as to how trust provision could look like with regards to ML systems, and what the implications of that would be for mechanism design, therefore radically changing what Web3 is able to provide to end users. So that moment was, at first I was in disbelief that this could be possible, both for scale reasons, but also like latency, every aspect that makes production systems really hard. And just seeing an unoptimized version of that work so well was the aha moment for me.
Very cool.
Yeah, I agree with that. I think like there are different things here. Like when I started in zkML, I thought that, and in zk in general, because I started zk, diving in zk thanks to zkML, and like I first thought that it will be much easier to like prove the integrity of any models, and then you realize the overhead that that it adds, when on top of these models. But then you also realize that most of the use cases that we have, and the use cases that we have for on-chain agents and financial machine learning in general, doesn't need big like huge machine learning model or an LLM, so because like in financial prediction, like basically you cannot predict a price, for example. So where it's important, where the machine learning is important in finance in general, is for risk assessment, or for like market conditions, market trends, etc. But not for like predicting the price. And we don't use LLMs in our agents. Why not? Or if we use them, we don't need to make them fully verifiable, you see. So making machine learning in ZK in a ZK circuit makes sense for this kind of models. I don't say that it's not possible to make more like bigger models, like big deep learning models with ZK. I have some ideas. There is also a lot of research on that, and some stuff that we want also to implement. So for example, something that we want to explore that was already explored by different teams and research in the past is for like bigger models like LLM. What we can do is, instead of proving the entire LLM, we can prove the watermarking of these kind of LLMs. So we are adding a watermark in the LLM, and we are proving the watermark extractor of these LLM, and the watermark extractor. What it will do basically, it will like proves you that the result inference is coming from that LLM. So if you manage to prove the watermark extractor, it means that you do basically the work of proving the entire, like proving the inference is coming from that model. It's just that you don't prove the entire LLM. You don't prove the entire LLM. So this is the kind of idea and thing that we want to explore, and that has been also explored by by research papers. But currently in our agents, we are using some agents for DeFi, and the idea of our research at zkML is to prove the decision making of these agents, or doing some doing some zkML pure use cases, but like we don't use it for like big LLMs. But yeah, it was that journey. You start by saying, wow, that's amazing to you can prove the integrity of any computation, and then you start to dive into it, and you see the overhead, and you see the challenges and also the opportunities here.
Yeah, that's super cool. Something I wanted to recap a little bit and make sure I got everything, or just to help people follow along. Like with ZK, we can prove the integrity of computations, and an AI model is its computation, right? So like you were saying, an LLM or like a large AI model, that's a lot of computation, maybe hard to prove, but you described a clever way to sort of sidestep this and still make it verifiable and know that the model that is supposed to be running was actually run through this watermark, basically proving I guess like proof that the correct model was being used, but you don't have to prove the entire execution or all the inference from the model. Is that?
Yeah, exactly.
There's also one other aspect that has been kind of our approach, or the differentiator of our approach, which I think is very visible in terms of looking at AI agents in Web3 as a category. Most things are kind of in the meme coin realm, where there's like a tokenized like LLM scaffolding that kind of people can interact with on social media and so on. And this is like our approach is radically more functional in comparison to that, where like what we wanted to do is to make the first like real agent, if you will, that actually provides a tangible utility to the end user, which we thought was 24/7 uptime, massive data ingestion and computation, security and operational precision. And all of this put together, we wanted to kind of bring this to the most high trust and security requirement area, which is finance, right? Like people have a lot of kind of trust requirements when it comes to managing their resources. And so we thought if we can manage to provide this utility under these constraints, then we can kind of, that is going to be how we can generalize this technology moving forward. So we kept those requirements very much at our crosshairs. So we said, okay, let's build an application, not just like the generalized capabilities to do so, not just the protocol, but let's build the application that people can use today that is going to make us understand what are the requirements an application, such an application that provides utility today needs from the protocol. So we built ARMA that effectively is stablecoin yield aggregating agent that operates again around the clock with operational excellence, with a very advanced cost-benefit function that it evaluates how it moves its positions from one protocol to another. And through building this and through reaching, the traction that it's reached today, effectively generating hundreds of millions in volume, we realized what we need to build on the protocol level in terms of trust provision, in terms of trust provision to the user, in terms of risk assessment from the target protocols that it's interacting with, in terms of latency, security, all of this stuff was made available to us thanks to our approach in terms of trying to not waiting for the application layer to come into being, but actually like making the application ourselves in order for us to sort of declutter our assumptions about what could be useful with regards to zkML agents, because again, like it's a very all of them are very kind of futuristic, has very, very futuristic claims. So at their intersection, it can become quite obscure. So we wanted to declutter that with being very praxis driven.
Yeah, I really like that approach, and I feel like I'm seeing a lot of teams approach things similarly. Like we have this deep technology or infrastructure, which has a lot of powerful use cases, but to make users understand or other builders understand what's possible, you need to show an example. And ARMA is your great example of this, which is live as well. I've played around with it myself. Super cool. I mean, just like very directly for people who are curious about ARMA and what it can do, like what should people know if they have some stable coins on base and they would like to have their yield optimized?
Yeah, I think the great thing about ARMA is that it's really first of all we have a lot of publications about it for people who want to dive deeper into the architecture, into the logic of the agents. But the great thing about ARMA is that it really reduces what you need to know in order to operate a very sophisticated on-chain strategy. It just allows you to simply deploy an agent that is completely non-custodial, that effectively controls a smart account that the user owns through a contractual relationship through session keys, so that it can execute on behalf of the user on the user's smart account that is newly generated. And then it effectively watches its target protocols, currently stablecoin lending markets, for providing the best yield to the user. So it has a certain cadence within which it operates currently. And within that cadence, it makes the decision to stay in a certain protocol or move to a new protocol. And these decisions are made on a per agent basis, even though their logic is pretty much very convergent today. But of course, if you are deploying at time t versus t+1, the decision is going to be different because the cost of switching a position, you have a different cost benefit function given the temporality you're operating within. So I would say that's all you need to know to get started with ARMA. But if you are more passionate, more interested into the affordances of on-chain agents, we have plenty of publications and more coming. So I would just go into Giza's blog for learning more.
So cool. Yeah. So it's basically you have your wallet, your end owner account, and then you, through that, deploy an agent, generate a smart wallet, you fund it, and then that agent autonomously will manage that account to optimize yield on base. Very,
Correct.
very cool. And of course, it's not deterministic, like you were saying. So if you deploy it later, or maybe you have more funds, less funds, how the market has changed, they follow the same strategies, but the exact trades may be different.
Totally. And
Okay.
the very unique kind of possibility space that this opens up is, of course, customization, where understanding better the user, understanding their risk tolerance, understanding their gas tolerance, understanding their appetite for a certain type of exposure versus another one. This is the direction that the agents are going to go towards in order to provide a much more high dimensional topology for user-centric execution.
Cool. So on the back end, like the logic of the agents, could you tell me a bit about the logic, the models that are running within the model, like if there's, I don't know, financial models, ML models?
So here something that is common to all of our agents, like this one and the ones that are coming. Basically, an agent here is a workflow, okay, where you have a part of automation and you have a part of decision making, okay. As Cem said, like we have different kind of customers. We have retailers, we have protocols, we have institutions that we are onboarding also now with ARMA and other agents that are coming in the future. And all of these agents have different trust assumptions, as Cem said correctly. And so in the automation part, the first step for a trust assumption is to make it self-custody. So this is why we implemented that with session keys. So like the user here is able to have full control of their funds. We cannot take any controls of their wallet, etc. So this is the part of with the session keys. Then we are working currently on the Giza protocol in order to decentralizing the agent execution. So the automation part of the agent will be very soon decentralized as well. So for the Giza protocol, we are building an AVS on top of EigenLayer, like you guys. And so this is for the decentralization of the execution of the agent. And then, as I said, there is a part of automation and there is a part of decision making. The agent needs to take decisions. This decision making can be heuristic or can be like more ML or more intelligent. And as I said, in finance, there is not huge models, but we are working on some, and we are implementing some ML models like market conditions or APR models in order to make the decision better for this. And this decision making, we are working to make this decision making verifiable. So that's why also we are investing time and resources in zkML, so we can have a full trust full trusted on-chain agents, where we have self-custody, we have decentralized execution, and we have verifiable decision-making of our agents, you see.
Super cool. I want to talk about the entire stack and all the things you're working on. One thing you said though before I do that is you've said a couple times there is no like master AI model that understands everything in finance and can predict prices accurately, but at least not yet anyway, right? Like maybe with the kind of work you guys are doing, that will be enabled in the future, if we can actually make some very good models verifiable and people are able to trust that it's significant amounts of assets can be controlled by these agents to get much better returns than how they would do themselves. So the full stack. I mean, we have the zkML stuff you're working on, which I think we should get into that in a second. You have the agent products themselves, like ARMA, which is live, and then there is the execution of the agents, which you are building in AVS to decentralize that and remove trust assumptions. So a lot of pieces there: product facing, infra, and then zkML research, which I want to make sure I get to ask you about that. So what I mean, I've seen stuff on all of your Twitters, and we've spoken recently, so I do know a bit about it. I would love to hear your stance on zkML, the challenges there, how you're approaching actually making these models verifiable, and what kinds of technologies are enabling that.
Yeah, sure. So we launched. We started to work on a library that we call LuminAIR. That is built on top of another library, a machine learning library, pure machine learning, called Luminol. And Luminol is a machine learning library, very similar to TinyGrad, if you are familiar with TinyGrad. The idea of TinyGrad of Luminol is that when you want to add a new backend acceleration, so for example, CUDA or GPU, on top of a machine learning library like PyTorch or TensorFlow, it's really, really challenging because like there are tons of operators, etc. And the idea of TinyGrad and Luminol is to make the machine learning that is really, really tiny, machine learning library that is really, really tiny. So it's really easy to add new backend accelerators. So in Luminol, there is only 11 operators that you need to implement when you want to add a new backend accelerator in order to like cover any kind of models. And then you can work on specialized operators that will fuse some primitive operators. And the idea that the idea with LuminAIR is to say, okay, instead of adding a new backend accelerator, we will add like a provable backend. So we started with the Stu prover of Starkware, and we are creating our own air components. So because in Luminol there is only 11 primitive operators, we had to start with and to cover any kind of models. We are implementing air components for each 11 operator. Okay, so we are creating our own air component with the Stu library. It's not related with Cairo. Okay, it's our custom air. And then we are building a compiler that will take a Luminol graph and link each primitive operators to a air component that is like provable with Stu prover. And what is nice is that in the future, if we want to add a new proving system, it's really easy because we just need to start with these primitive operators if we want to add that. But it's not because so this has different advantages. As I said, in the kind of machine learning models that we are building, we need to have that flexibility to don't be stuck with just deep learning models, and we need to have that flexibility to cover other kind of machine learning models. And here we can represent easily a ML model as a computational graph. So it's not only focused on deep learning, it's like machine learning, deep learning, or even like any computational graph that can be provable. So this is like the advantage to have that, the flexibility. And then we can, in LuminAIR, we can like we can implement different compilers that will be stackable before the inference. And all the idea of LuminAIR and why we decided to build that on top of LuminAIR is because there is there is the design of composable compilers where but anyone can create their own compiler. And what is a compiler basically here is just a program that will be computed before the runtime, before the inference, in order to modify the graph, the computational graph, for a purpose. So the first compiler that we are building is the LuminAIR primitive compiler that will link each operator to an R component for primitive operators. But then we will, once we finish to implement these primitive operators, we will build the Fusion compiler, and this compiler will check the graph and find patterns that can be fused in a more optimized operator. So to give you an example, in the set of primitive operators, there is no matrix multiplications, but there is the multiplication and the sum reduce. Okay, the Fusion compiler, what it can do, it can find, check the graph and find patterns. So when the multiplication operator is followed by the sum reduce operator, and fuse that primitive operators in one optimized R component for matrix multiplications. You see, and we can do that again and again and again, but based on the use cases that are coming to us, and we are not like taking the months and months trying to build the best zkML library. Like we are fusing operators based on the use cases that are coming to us. And of course, it's like open source. So anyone that wants to like optimize the graph, they can like implement their own compiler and submit a compiler in order to fuse these operator. So this is the idea. The idea is to have the flexibility for the proving system, for the graph, for the use cases. Yeah, so that's the idea of LuminAIR.
Okay, very cool. So it's like a library that allows you to, well, AIR, that's a arithmetic intermediate representation, right? So that's a prerequisite for proving this computation. So it's sort of a system that allows different, provers to be used to prove the ML inference ultimately.
Exactly.
Okay, super cool. To break things down, like, why is this so important for giving on-chain agents superpowers, if we want to call it that, or capabilities that users would desire? I mean, I have an answer for that I think, but I feel like you probably have.
I would love to hear your answer.
Well, my answer basically is that if we're going to have on-chain agents acting on our behalf, managing our assets on our behalf, and they're doing this based on decisions that are coming from machine learning models or other computation, I think it's important for this to be verifiable, because you need to know that it's actually doing what it's supposed to be doing. And if there's, if there's a problem or you take a loss, you can interpret that and understand why that happened to improve your risk management or improve the models. So you need to be able to verify the computation that is leading the agent to take some actions if you're going to, trust it with your money, basically.
Totally. 100%. I think this level of trust that verifiability provides, it's really branches out when you zoom into it. It's like depending on the use case, because finance, again, is a big cloud of economic functions, and within them there's you have things like execution based on certain signals, you have risk assessment, you have credit worthiness, you have all these type of you have insurance, again another version of risk assessment, you have gating functions, whitelisting, blacklisting, decentralized recommendation, a lot of functions that all have different requirements for trust, right? Like and some of them come from like reducing counterparty risk, where I'm getting the service from an ex-developer that I have never met in my life. I do not have this kind of trust mechanism established with, and ZK acts as ensuring me that the model that is demonstrated to me to have certain backtests, to have certain performance metrics, is going to be the model that is going to be executing my agent, right? So like it's a specific component inside of the logic of my agent that is a key component for me to get to the performance or the exposure that I want to get to. But I want to know that this is the like the performance that I see that is advertising is the performance that I'm getting. In other functions, like for things like risk assessment, I want neutrality, right? Like I want to make sure that no one is bribing the model to get ahead and skew the decision making of the model towards something that benefits the target protocol instead of benefiting the user. So I think there's many use cases for verifiability, but some of these are making it clear how critical they become when there's counterparty exposure involved, which like in permissionless systems, this is almost a given, right? Like we are trying to bring coordination to like more hops on the social graph. So that requires these trust technologies to be in the loop.
Another
that makes a lot of sense. Yes, Raph.
Another use case that I think make really sense for verifiability, and it's a use case that we are working on and we will launch in a week or two, is for content recommendation. And it's not a financial use case, so I think it's also interesting to dive into it because it's also a use case where zkML makes sense outside of the DeFi world. It's for content recommendation. So for example, Twitter, 2 years ago, they open sourced their recommendation system. So the post that you see on the feed, it's coming from an algorithm that is recommending you the post that you see on the feed. So it's nice because they open source the recommender system, but it's a first step. But when I'm checking my Twitter app, I have no idea that the feed that I see is coming from the result of the recommendation system that they open sourced. So something that we are working with a news website. I cannot say which one yet, but soon. And the idea here is to verify, to prove the content recommendation of these blog posts, because I personally, I don't want to live in a world where we have these social apps or these news websites that is like recommend that is have this huge power to like pushing you the content that they want you to see, you know. And here with verifiable recommendation systems, here we can prove the result of the, like, we can prove the computation of these content recommendations, and we can also make this recommendation system open source as well. So like users work together on a fair and yeah, a fair algorithm, but we also ensure that what I see is coming from exactly this algorithm, and I'm really attached to that use case, because I think all these Farcaster and Lens protocol apps, etc., if they want to be decentralized social apps, I think they need to make their recommendation systems verifiable as well. Otherwise, it doesn't make sense for me. Like the content recommendation is at the heart of all social apps, at the heart of all news blogs, websites. So we need to make them verifiable, and I think this is a real good use case on where verifiability and zkML makes sense outside of the DeFi world.
I'm so happy you brought that up, because the next thing I was going to ask was what are some use cases outside of DeFi that you guys have been thinking about? And I already kind of knew your answer to it, but I was gonna prompt you with that anyway. Yeah, no, I think that's super important. I mean, that in a lot of ways gets to at least what I feel is one of the main points of crypto and Web3, which is not having to rely on these centralized entities and to trust them with all of our data, and trust that they're going to serve us, let's say, the content that we actually want to see. Because realistically, they're serving us the content that's going to keep us on the platform longer, so they can sell more ads and make us look at the screen more. But that's not very human centric. And
Yeah.
I think when people start to think about that, they realize, like, if people think about this, they realize the problem. And then, you know, if they start thinking about solutions to the problem, they probably get to learning about zk and crypto,
Yeah.
because without these tools, wasn't really possible before. So
yeah, definitely. And however, I think the real challenge here is how do we onboard like people that are not coming from crypto, or even crypto users that have no idea what is zk, and how do we how do we visualizing zk, how do we visualizing the verifiability part, you know. But I think it makes sense. Like when you are on your Google Chrome window, when you go to a website, you see you see the locker, you know, on the HTTP bar. So even if you don't know what is a TLS, etc., you know that this website communication is secure. You know, at least that website is secure. You know, and we need to find these kind of design patterns where non-advanced user can like just understand that there is verifiability of computation integrity, or there is something that is trustless, or something that I can trust, you know, at least thanks to that. So it's also our work with LuminAIR. LuminAIR is not only a machine learning library, zkML library. It's also a React and JavaScript library. So we just released LuminAIR Web, and with this use case of like recommender system, we will we added a badge, you know, a verifiable badge on the website, where users can like see that the content recommendation is verifiable, and this is a React component, and this will be open source. So like anyone will be able to add this kind of of React components in their website also, and use that with their LuminAIR. And I think we will continue to work on different React components, because like UI kit at least, because I think it's really important to like see how we verify we design the trustlessness of our web, the web integrity, in the same way that there are some UI libraries for Wallet Connect, where you are connecting your wallet for Stripe like models, where you can integrate that directly on your website. I think we need to visualize the trustlessness as well. So it's also a part of LuminAIR. It's that also.
Yeah, no, that's amazing. I mean, it's clear that the vision you have at Giza is much more than just, an agent that optimizes your yield for stablecoins, but the tools that allow people to build those agents and to make those agents verifiable and to extend that to, I guess, user experience needs that are ultimately important that people probably don't really think about. But when they do start thinking about them, it's usually too late. It's like something bad has happened when people realize this. Awesome. And yeah, I'm going to wrap things up in a second because I want to be mindful of your time. And I know it's getting late for you guys, but maybe next time we'll be able to talk about some of the cool things that we're working on together, which we're still being kind of secret about. But I've mentioned, at least on Discord, that we're working on some cool stuff using zkML that uses a line to verify that people will actually be able to integrate or interact with, rather. But yeah, to close things up, what should people look forward to from Giza? Like, what do you want people to do? Check out ARMA, of course, I'm sure, but like, what's coming?
Yeah, we're going to. We have been, and we will keep on doing so. We will keep throwing weird things at people to try out. I think what's really a blessing to be in Web3 is that we're just like surrounded by early adopters, and we try to be deserving of that energy and with trustworthiness that we want to provide through everything that we talked about in this podcast. And so what I would love people to do is just to press all the buttons, try everything, try to break it, and just like also try to get an idea of like where we want to take this, which is a new way of interacting with permissionless protocols, a new way of a new user experience, a new type of interfacing finance. And I think if you see a glimpse of that, these use cases that Rafa is talking about, what our agent is providing today, or what our future agents are going to provide tomorrow, it's going to be very tactile, and for people to understand the type of future that is incoming. And yeah, what I would wish for everyone is to be part of that.
Amazing. Raphael, any closing thoughts to add to that?
I think it was pretty clear here what Cem said. Maybe a word about LuminAIR, and because LuminAIR is open source, and people can start building on that. People can start contributing on LuminAIR, and they can also start to build some use cases like zkML use cases. I'm happy to dive with some ideas of builders. So feel free to send me a message, and I'm gonna answer you. And like, I'm happy to help you trying to build some zkML use cases, and we can also think about how we can help you and push you on that part as well.
Amazing. Yes, building in the open. We love it. And yeah, I'll even plug ARMA as well, because Cem, you mentioned, you know, the UX of these things. You know, you guys are trying to bring kind of something completely new in a lot of ways to how people operate on chain or operate, you know, in terms of managing their finances. I played around with it. It's cool. It was interesting. All the session keys, it all worked very nicely. I'm excited to keep following along, and it's definitely a big UX improvement over my current, you know, I have my safe multi-sig and I'm looking at lending protocols, and I probably just go with Aave because it's really easy to use and I don't have a lot of time to be searching for the best yield. And I'm thinking, well, do I trust this protocol? And I'm definitely not moving those positions regularly. I just kind of like let it sit there, and I'm happy to, you know, get some yield on the USDC I have. But yeah, I see this being a really big thing. And with that, I'm going to let you guys go. Raphael, Cem, this was a pleasure. I really appreciate your time. Thank you for joining. For everyone listening, I try to do these streams at least twice a month. So if you have speakers that you'd like to hear from, please let me know. Past talks are on YouTube. Check out Giza, check out ARMA, and we'll see you next time.
Thank you, Boris.
Thank you for having us.
All right, guys.
It was great.
Bye.